Good morning, Year 10 5.3 Mathematics students. Today we're continuing on with the topic of probability and we're learning about conditional probability statements. So the mathematics associated with the probability that an event occurs given that another event has already occurred is called conditional probability. Consider, for example, a group of students who own bicycles. Some of the bicycles have gears, some have suspension, and some have both gears and suspension. Consider these two questions. What is the probability that a randomly selected bicycle has gears? What is the probability that a randomly selected bicycle has gears given that it has suspension? The second question is conditional, in that we already know that the bicycle has suspension because it's told that given that it has suspension. So the probability of an event A occurring, given that the event B has already occurred, is denoted by P A straight line B, which reads the probability of A given B. So the probability of A given B equals the number of elements in A and B over the number of elements in B. So for example, in this Venn diagram, we have the probability of A given B. So the probability of A given B is the inside bit here, which is 2, over the total of B, and our total of B is 2 plus 5, which gives us the 7. So if we look at the two-way table, the number of elements in A and B is 2, so that goes on the top, and the number of elements is B is 7, so that goes on the bottom. The probability of B given A is just the opposite, so it's the number of elements in A and B over the number of elements in A. So for the diagrams above, so if we were to look back up here, we have that the probability of B given A, so that is the number of elements in A and B, so that is our 2 in our Venn diagram, and then it's the addition of everything in A, which is 6, which equals 1 over 3. And again over here, it's the probability of the number of elements in A and B over the number of elements just in A, or all in A, so 2 over 6. Let's have a look at some examples. So we want to consider this Venn diagram, which displays the number of elements belonging to the events A and B. We want to find the following probabilities. So if we have a look at our tree diagram, we have the elements of A and B, or the events. So the probability of A, so that is everything. So the probability of A is just everything in A. So everything in A is everything that is enclosed in this circle. So it's the 3 plus the 2, which is 5, over the total. So our total will be our 3 plus our 2 plus our 4, so our total is 9, so it's over 9. So then the probability of A and B, so the probability of A and B is everything that crosses over, so that is this bit here, so that is equal to 2 over our total of 9. Now the probability of A given B is going to be the what is in both, so what is in A and B, which is 2, over the probability, or what is in B. So everything that's in B is everything in this circle here, which is the 2 and the 4, which adds to give 6. So our answer is 2 over 6, and we want to simplify this down to 1 over 3. And then we have the probability of B given A. So when we talk about that, we look at everything in between. So the probability of what's in B and A, which is 2, over everything in A. So everything in A is 3 plus 2, which is 5. Moving on to example 2, we have from a group of 15 hockey players at a game of hockey. 13 played on the field, 7 sat on the bench, and 5 both played and sat on the bench. So a hockey player is chosen at random from the team. let A be the event the person played on the field. So that's what A is going to be. Let A be the event the person played on the field. And then let B be the event the person sat on the bench. So our benchies are our Bs. So part A is to represent the information in a two-way table. So from our information, we have that, if we read it through our information, we have 15 hockey players. So that means our total of our totals here is going to be 15. We have that 13 players played on the field. So the event that the person played on the field, the total of that's going to be 13. And we have that 7 sat on the bench. So the total of the bench will be 7. And then we have 5 both played and sat on the bench. So both is when we have A and B, which is here. So then we can work out the other bits of information. So we want our A column to add to 13. So 13 minus 5 gives us 8. So that means A, not B, is going to be 8. We want our B row to add to 7. So 7 minus 5 gives us 2. So that means that B, not A, will be 2. We then can work out what the total of not A is going to be, because we go 15 minus 13, which is 2. And we can find the total of not B by going 15 minus 7, which gives us 8. So that means that there is 0 players that played neither. Okay, now we want to find the probability that the person sat on the bench only. So if they sat on the bench only, that would mean that they did not play on the field. Now remember, playing on the field is A, so it's going to be not A but B for bench, which is 2, over our total, which is 15. So 2 out of 15 did not play on the field. Now we want to find the probability that the person sat on the bench given that they played on the field. So now we're talking about when the probability of B given A. So what we do is we find the probability of both, so the number in A and B. So our number in A and B is 5, and then we're going to put this over the number in A, which the number in A is 13. So our answer is going to be, still in highlighter there, our answer is going to be 5 over 13. And finally for D, we want to find the probability that the person played on the field given that they sat on the bench. So we're finding the probability of A given B. So again, we find the probability of both, or the number in A and B, over the number in B. So 5 over 7 is going to be our answer there.